In this video, we're going to see how we can batch process images. So the idea is to process 31 images where we see nuclei stained with DAPI. So this one, you know it. We have 30 other images that were acquired with the same instrument, and the samples were prepared the same way. So we're going to use the same pipeline that we defined in the first session. So I'm going to open the macro recorder to record each step, right? So let's go. First, we open the image. When we apply a median filtering with a kernel of 2, then we threshold the image. And last time we saw that Huang was fine, so let's apply the Huang thresholding. Now here we don't need to fill the holes, but maybe with other images the thresholding wouldn't be as good, or we would have some isolated pixels from the background inside the nuclei. So let's just apply process binary fill holes, so we make sure we don't have this, and finally we apply a binary watershed. Now we have identified the nuclei, so we can extract the rows associated to each nucleus with analyze particles. So we make sure that add to manager is checked because we want to add all the rows to the row manager. And now we want to extract measurements on the original image, so we're going to open it again and we're going to add the row on top, and now we do measure. Alright, so let's create this macro. And now when you have macros, or more generally when you code, it's always nice to add comments so you better understand when you go back to your code, you know what you did, or if you share it with other people, it's easier for them to understand. So if you use slash like this, you can comment. So we're gonna add a comment for each line. So here you see we do open, and that's the name of image. So we actually open an image. Then here run median, so that's apply median filtering with a kernel of 2. So here we apply the Huang threshold. So then we see that this line is in common, so we can get rid of it. And if we look at here, so set auto threshold, Huang, set option, so that's an option associated with threshold, and then convert to mask. So these 3 lines are actually applying the Huang and extract the mask. Then here we apply fill holes. Then we apply a binary watershed. Alright, then we add rows to the row manager. Then here we open the image again, open image. And then here, so you see there's show none, show all. It's because I had to uncheck because it was already checked, and then check show all. That actually I can just get rid of this and then show row overlaid. Okay, on the image, and finally extract features. Alright, so now I can apply this macro and see what we get. So we have several problems, and we're going to start with one that is visible right here. Now we have 4 images open, so actually we open image is to do the analysis, but we don't close them. If we have to batch process a whole set of images, we're going to end up with many images, and that's not very convenient, so we should close the image. And there's a simple command to do that, which is actually run and then close all, capital A. Alright, and as you see, every single line ends up like this. It's because it tells the computer when the command is over. Now, something else that we can also see here is that the first row is not number 1, but is number 105, and it's actually because we had 104 rows. In this image, we can see that the last one is 104. So in the first analysis, and then we started at 105, it's because we added new rows. Now, alright, here. So this is the first 104 rows, and then we added the new 104 rows because we didn't clear the row manager, and that has a direct consequence here. If you look at your results, you have first 104 results, so that correspond to a first analysis, and then as we have as many rows, we should have 208. But if we go to the end, we have actually 312. It's because for the first analysis we had 104 rows. For the second analysis we had the 104 rows for the first analysis and the 104 rows for the second analysis. So we did it twice. So it shows that we need to clear the row manager, otherwise we're gonna count several times the same thing, and here it's the same image, so at least it's just a repetition. But if you apply the row for this image on another image, it won't have any kind of meaning. So we need to clear the row manager. And there's also a easy way to do it. So clear row manager, which is actually so to get rid of all rows, and here is just row manager, and you see you have all of this. So we could do delete, but we can do even something more radical, which is reset. So make sure that we get rid of everything. Okay, so we reset the row. All right, so now let's run this. Good thing is that we don't have anything, any image open. We don't have anything in the row, and again I did the same. I don't know how I do that. We don't have anything in the row. Now there's an obvious additional thing that doesn't make a lot of sense, is that we always run the same image. So of course we see here we have a direct path to the image, so we could change here the name of the image. So here and here for each different image, but you know, we would have to change it every single time, and that's not the smartest way to do it. Obviously we can automatize it and, for example, batch process all the images that are in one folder. So in order to see how we can do that, we're going to use a template. So if you go to templates, image J1X batch, and here we're going to use a process folder. So that's the template. So as you can see, we have, to start with, we have 3 different inputs that the user is going to define, which corresponds to the input directory. So it's a directory and it's defined as input. An output directory, which is also a directory and defined as an output, and then it's a file suffix, which is a value and is defined as suffix. So we're going to define where the image to process are, where the results have to be put, and what's the suffix of the image we want to process. Okay, and then if you look at it, you have 2 functions: process folder, process file, and so after the input are defined, the computer will just do process folder of input. So if you go to process folder of input, you see that it takes get file is an array sort. So basically it takes everything that is in input and sort them. And then for every single value that is in the input, if it's a directory, it's gonna reprocess it. So that's what we call iterative. If you have a folder, then it's gonna ask the same thing inside the folder to see if there are other files. And otherwise, so if it's not a folder, it's gonna look at the value list of I. It's actually the value, so it's one file basically here. It would be one file, and you're gonna do process file of input output. So the input directory, the output directory, and it's gonna process this file. And what is process file is the second function, and that's where you actually do things. So you process your images. And here is just an example. So it's gonna print processing input plus file, so input directory and the files that are in this directory, and saving where you want to save. So let's just run it to see what it gives. So you see here, you define the input directory, so which in our case is going to be, so in image example is going to be nuclei images. The output directory, so let's define a new output directory, which is going to call, for example, nuclei images output. Simple. All right, we select it, and the images we want to process are TIFF images. All right, and now if you look at what we have, so it says process. This is the input directory, and then this is the first file, second file, third file, and if we go like this, we're going to have 31 files. Okay, so the nice thing is that we can actually get every single image, so we can process each image at a time, and if we need to open it again, we can open it again. Like for example, here we want to do segmentation, and we end up with a binary image, then we want to open it again to add the rows. Here we're going to be able to do that. So let's go back to our macro here, and we're going to copy and paste. Yep. Not that. So copy, and we're going to add all of this here. All right. So now you see generally you have an indentation, so we're going to do it manually just because it's easier to read codes when it's when you have a nice indentation. So it's just the time to do it. All right, and now we're gonna change the open so that corresponds to our file. Instead of processing all the folder, we're gonna define a subfolder. It's always fine because when you try to batch process, most of the time you're gonna make some errors, and instead of batch processing, if you have like 1,000 images and it's just going wrong, you don't need to spend that much time. So we're gonna just define a new folder, nuclei images subset, and we're just gonna put 3 images in first 3. All right. So now what we have to change is when we open it. So instead of opening and with the entire file, now we're gonna do, so when we run it, we saw that this was exactly what we wanted to have. So let's copy that and put it here. Okay, and we're gonna do the same thing here. All right, I'm just gonna put this comments and let's run it and see what it gives. So here I need to define the input, so I'm gonna define it as subset. All right, and the output is not needed for now, but let's just define it as the output. All right, so if we go to the results now, you see that you have this image, and if we go up, you see this file is different from this one. So that's the last image, that's the second, and we should have one more image here. So we processed the 3 images, okay? Something that we can already see is that we added all of this right after everything else. So we need to clear this when we start the file, otherwise we're gonna just add after what is already there. So if there's nothing, it's fine, but if there's already something, it's not. So that's something we should do here. And by the way, just to make sure we don't do anything wrong, we should always also close all images and clear the ROI manager, just in case there's already something and that's gonna just mess up the analysis. So let's do this. All right, and we need to clear the results. And here, let's just run and clear results. So you see, most of the time, that's pretty straightforward. All right. Oops, that's not what I wanted to do. Yeah. Okay. So here we make sure that we clear everything that is there. So that's one thing. Now the last thing that we haven't yet done is to have some output. So this will be our output with all the measurements. The risk when you do that is that you don't see what you actually do, and maybe there's going to be images. So there's several reasons. Maybe your pipeline is not suited to all your images, and you're going to process partially or not the way it should be some images, and if you just look at your result here, there's no way you can know. Maybe you have some images that act as outliers too, and they won't be processed the same. You can't process them the same way and it won't work. How can you know that? You should always add an output that allows you to visually inspect the results. Okay, so what can we do here? I'm gonna go back here and I'm not gonna close the images. I'm gonna run it just to get this. Oh, but I closed the ROI manager, sorry. Okay, let's run it again. And you see here, this is a good visual inspection of your result because you see your original image and you see a representation of your results, which corresponds to all the ROI. So let's go from here, and we're gonna, so the macro recorder is still open, so we're gonna record a few things. What can we do here? There's two things. Maybe the contrast is not good enough, so we can't, so let's just open adjust and brightness contrast. We cannot do it manually. That's what we do, and that's what you should always do when you analyze. But here is just to inspect the results. So maybe we can just do it the auto, and that's not the best way to add contrast and everything. But again, if you just want to inspect the results, that's going to be fine. The second thing you need to do is to make the ROIs part of your image, because when you visualize the ROI as our overlay. So if I save this image, I won't save the ROI. And it's simple to do it. You just go to Image, Overlay, and Flatten. And now I have an RGB image where you have the original image and the ROIs are in the image. So now if I save this one, so let's save as PNG, and let's save it in so if I go image example, let's save it in the output, yeah, and let's save it. So that's I guess that's the name, maybe not, but it's okay because we'll use the output in the macro. So let's just save it, okay, and now it's saved. Why I did that is I wanted to get those different comments, and I want to add them in my macro. So if I go back to my macro here, before closing everything, because if I close all my image, I'm going to miss this. So what do I do here? I enhance contrast. So that's, as I said, is just to if you have nuclei that have a low intensity or nuclei with very high intensity, and so you don't see anything with that, you'll be able to inspect your results, okay? And this actually is so add overlays, so add the ROI to the image, okay? And the last one is save visual inspection. Now again, I don't want to define the name, but what I can do is use the output directory now. Okay, so let's just get rid of this, and I'm gonna define output. So that's the output. Okay. Thing is that the output is just the directory, so I need to define the file, which is called file. So it's gonna have the same name than the input file, and then it's a PNG image. I'm just gonna add .png. So you see these are variables, so that's why they are not between separators, but here we need to do that because that's what we want to add as characters, okay? So that might be a little bit more specific, but when you see an example like that, then you know how you can apply it for other examples, okay? So hopefully this is gonna work. Let's try it. Again on the small subset, just to make sure that it works. Nuclei image subset. I'm going to put in the output directory, okay, and let's run it. So you see it takes a little more time because we have to do this step. Now let's look at different image. So here we have the last one. Maybe I went too fast. Yeah, second one, and then the first one, and you see the first one we only have 104 rise. So what it means is that we cleared the result before, so we don't have the previous result. So here everything seems to work fine. Let's have a look just to the output. So this didn't work. Oh, okay, so it didn't put them. Okay, so you see I forgot something, because here I have the input, but it put the folder name, nuclei images output, and directly then the name. And so if the image is correct, but the path was not, and it's because I didn't do it correctly. And I guess, so let me check, how do we do it for the input image? We have a file separator. So we need to do that to say that this is, you see here we have a folder and then a file. So let's copy all of this, and here it's the same thing, output, and I have the file separator to say that, okay, this is a directory and then this is a file. So, oops, sorry, it's just that I have two pluses now, I just want one. Let's run it again. So now it should be the right one, but let's just make sure. Subset, output, let's run it. Okay, so this runs. Now let's just look at here in the output. Yeah, now see, work fine. So that's the first one we saved, the first one, okay, and you see we didn't save it the same way because we didn't have the same contrast. So now that's what we have. Looks good to me. So let's just remove everything. Oh no, it's because first time I saved it as anyway, it doesn't matter. Let's remove everything, and now let's delete that, and let's run it, but not on the subset, but on the entire folder, and let's run it. So you see, it takes some time just to save the image. Oh, we saw that there was something odd here. So you can, when it's running, you can look at the results, so you have an idea of the accuracy of your result. But as we have this visual inspection, now we can go back to it. And we just saw that there was an image with a problem. Other than that, it looks okay. So now, if I go to my result file, I have 31. Sorry, I can't, okay. Well, but we have, yeah, almost 4,000 nuclei total. So if I save it, so let's save it in the output folder, save it as result, and now let's go back to the so the output. So I have a result here I can open with Excel or any software that can read tables, and now you see, so you have the name of your images followed by something that corresponds to the right identification. So we have all the measurements, and we have the 31 images here. So that's the last one, and we change here. Okay, so that's all the information. So here, that's where you have the numbers you want to use, and then you can go through your images and see if it looks fine or not. So maybe here you say, oh, I should have something more aggressive to separate nuclei, for example, because this one clearly don't belong to the same component. And we had something like this in here too. So, you know, that's something, when you look at your result, maybe you see you want to go back to your pipeline because it's not exactly what you would like to get. The other advantage is that you can go through your result, and here, okay, there's something wrong. We see the nuclei, but we segmented something that is not. And it's probably because the image had some artifacts. So we can have a look. So if we look at it, that's the name. I'm going to try to go back to it. So if I go to Fiji, that's right, we can directly see it here in the output. So that's 6. So let's open it in the input. It corresponds to this one. And we see we have uneven illumination. So there was some problem during the acquisition. So when you see that, either you decide that, you know, I cannot use this image because there was a problem in the acquisition, or I want to process it differently. And you can go through your results like this. So maybe this one, it's fine, it's fine. And here, clearly it is not. So let's open this one. So which name is it? Maybe I should, yeah. So I'm gonna look in the output, because in the output it's RGB images, so you can see. So that's okay. They are organized the same way, so that should be this one. And You see, it seems here that there's nothing. Yeah, you see you have values between 118 and 208. So it means that it's just background. So there's no nuclei. However, our pipeline tried to identify something, so it identified this small object. So here clearly, either you try a different way to do it, or you just disregard because there are no nuclei in this image. And that's it. So that's how you do your batch processing. So you see how powerful it is. You can obviously you can process a very large amount of images, which is always great. It will be reproducible because when you save that, you can even share it with other people, and they're going to be able to process their images the same way you do yours. You can reuse if you have, for example, the pre-processing, you want to do the same thing for another application, you can go back here and just copy and paste. So that's really, really powerful, and I know you're not experts in coding, but it doesn't require a lot of expertise, and it's really worth the time spending because it's going to allow you to do much more reproducible and much more powerful processing. One last thing maybe I didn't mention, so we get the results here. I save it manually. You could actually save it here, so let's just, I don't know what it does, but I guess here that should be recorded in the macro. Let's just try save it. I'm gonna erase. So yeah, so you see you could add it. So save results and save as some results. That would be that's this results, and then instead of doing this, we could copy and paste what we had here, except that so that file, so we want it to be in the output folder. So we would do, sorry, something like this, and then let's say results.csv, and just if you want to check if it works, we can just run it again. And now we're gonna save the results directly in the output folder. And so you make sure that you don't forget, because if you batch process your analysis, you can even batch process the way you save your results, and so everything is you make sure that you don't forget any step. So now if I go in my results, so I use the same name, but so I saved it in the right folder, and I saved it with the results, and now I can access them directly.